thinking. So I'm going to read the paper and then I'm going to leave my thoughts on it. Memory requirements of today's workstations typically jump substantially from several to many megabytes whenever there is a new software release. When demand surpasses capacity, it's time to buy add-on memory. When the system has no more extensibility, it's time to buy a new, more powerful workstation. Do increased performance and functionality keep pace with the increased demand for resources? Mostly the answer is no. About 25 years ago, an interactive text editor could be designed with as little as 8,000 bytes of storage. Modern program editors request 100 times that much. An operating system had to manage with 8,000 bytes, and a compiler had to fit into 32 kilobytes, whereas their modern descendants require megabytes. Has all this inflated software become any faster? On the contrary, where it is not 4,000 times faster hardware, modern software would be utterly unusable. Enhanced user convenience and functional supposedly justify the increased size of software, but a closer look reveals these justifications to be shaky. A text editor still performs the reasonably simple task of inserting, deleting, and moving parts of a text. A compiler still translates text into executable code, and an operating system still manages memory, disk space, and processor cycles. These basic obligations have not changed with the advent of Windows, cut-and-paste strategies, and pop-up menus, not with the replacement of meaningful commands words by pretty icons. The apparent software explosion is accepted largely because of the staggering progress made by semiconductor technology, which has improved the price-performance ratio to a degree unparalleled by any other branches of technology. For example, from 1978 to 1993, Intel's x86 family of processors increased power by a factor of 335, transistor density by a factor of 107, and price by a factor of about 3. Isn't that crazy? The prospects for continuous performance increase are still solid, and there is no sign that software's ravenous appetite will be appeased anytime soon. This development has spawned numerous rules, laws, and corollaries, which are, as is customary in such cases, expressed in general terms. Thus, they are neither provable nor refutable. With a touch of humor, the following two laws reflect the state of the art admirably well. Software expands to fill the available memory. Software is getting slower more rapidly than hardware becomes faster. The former quotes from Parkinson, the latter quotes from Razer. Uncontrolled software growth has also been accepted because customers have trouble distinguishing between essential features and those that are just nice to have. Example of the latter class. Those arbitrarily overlapping windows suggested by the uncritically but widely adopted desktop metaphor, and fancy icons decorating the screen display such as antique mailboxes and garbage cans that are further enhanced by the visible movement of selected items towards their ultimate destination. These details are cute, I agree, but not essential, and they have a hidden cost. So causes for fat software. Clearly, two contributing factors to the acceptance of ever-growing software are 1, rapidly growing hardware performance, and 2, customers' ignorance of features that are essential versus nice to have. But perhaps more important than finding reasons for tolerance is questioning the cause. What drives software towards complexity? And before I continue, I will read my comments on this paper so far. So, the title of my useless paper is I Really Love Wirth's Writing Style. Yes, that is the title because that's what I want to convey. Actually, I believe things in life should be simple. That means whatever exists in my life should be simple. Yeah, that sounds better. I like simplicity. Therefore, I think my software should be simple, since it is such a huge part of my life. I also think languages should be simple. I speak 4 languages, none of which I can use well. That is because I learned human languages just barely enough to be able to communicate in them or be able to express my thoughts in one way or another. That's why I have always considered too complicated words such as impotence, monolithic, or incentive are not worthy of my time to learn, since there are much simpler words to describe their meaning, and I already know their simple translations, so why should I learn the more sophisticated words? That, I believe, is because I fell in love with how Wirth writes. He uses complex words, but with the way he puts them in the context, somehow even a complete degenerate like me is able to grasp the essence of it, to catch the gist, to taste the flavors that he has put into this mere 5-page long paper that I am reading right now. And it is yet so meaningful and so beautiful. That is how I want my papers to be: short, cohesive, and purposeful. That's why I need to learn such words, one by one, and I will. So, common folks claim you are what you eat, but I think you are what you use, you are what you write, you are what you consume, and you are what you think. Therefore, I sincerely love this paper. I've collected some of my favorite quotes from it to be available to the public if I ever figure out how to self-host in Japan one day, or in this case, I'm just going to publish this on a PeerTube instance because I don't have another choice right now. Okay, quote. When a system's power is measured by the number of its features, quantity becomes more important than quality. And before I read my comments on that, I want to read what Wirth has to say about what drives software towards complexity. A primary cause of complexity is that software vendors uncritically adopt almost any feature that users want. Any incompatibility with the original system concept is either ignored or passes unrecognized, which renders the design more complicated and its use more cumbersome. When a system's power is measured by the number of its features, quantity becomes more important than quality. Every new release must offer additional features, even if some don't add functionality. Now, let me tell you my comments on that. And this is not only about software, it is about absolutely everything in our lives. In my life, for example, we all probably know, or if someone doesn't, it is popular in medicine to give advice to consume ingredients rather than ready-made products. And why is that? Because the ingredients are the sole features that we need to nurture our body with the correct nutrients. When instead of a potato, we eat potato chips, we consume so much more necessary substances, which is called bloatware in software, instead of the ones that we need. Thus, it becomes easy to imagine that indeed when any system's power is measured by the number of features, quantity becomes more important than quality. Okay, let me continue. All features all the time. Another important reason for software complexity lies in monolithic design, wherein all conceivable features are part of the system's design. Each customer pays for all features but actually uses very few. Ideally, only a basic system with essential facilities would be offered, a system that would lend itself to various extensions. Every customer could then select the extensions genuinely required for a given task. Increased hardware power has undoubtedly been the primary incentive for vendors to tackle more complex problems, and more complex problems inevitably require more complex solutions. But it is not the inherent complexity that should concern us. It is the self-inflicted complexity. There are many problems that were solved long ago, but for the same problems we are now offered solutions wrapped in much bulkier software, because increased complexity results in large part from our recent penchant for friendly user interaction. I've already mentioned windows and icons, colors, grayscales, shadows, pop-ups, pictures, and all kind of gadgets can easily be added. Now, I want to leave my comments on this. On the quote that it is not the inherent complexity that should complex us, it's the self-inflicted. Now, this is a word that does not yet exist in my vocabulary, but I understand what it means. It means complexities that arose from yet other similar complexities. and once we look up the definition, inherent, naturally a part of a consequence of something. Complexity that is naturally caused by other complexities are confusing for us humans. I'm even confused reading this sentence right now, because they are self-inflicted, and indeed, I wrote this sentence and I made it complex for myself, because I'm trying to explain it. We create problems, then we give solutions to the problems we created. That makes me recall how businesses tend to fool the public as if they need containers and containers for the containers or products that already come in with containers. It used to be, maybe it is now, popular to sort your new pasta in a container that you put a label on it, you write pasta. Your flour to another container, you write a label on it, flour. But the pasta, the flour that you bought already came in containers that had their own names or logos written on them. Therefore, you create solutions to problems that did not need a solution. It is exactly the same as software. How many times did one think, why are there so many features yet so few of them are actually useful? Okay, let's continue. To some, complexity equals power. A system's ease of use always should be the primary goal, but that ease should be based on the underlying concept that makes the use almost intuitive. Increasingly, people seem to misinterpret complexity as sophistication, which is baffling. The incomprehensible should cause suspicion rather than admiration, and I have something to say about that quote. I wonder how many people have ever looked at the Windows operating system and thought to themselves, wow, there is so many things in this operating system, it is so admirable. And actually there have been many. But then there's this thing, why do folks of older generations struggle with technology? I think because it is too complex. And as I said, complexity is not a sophistication, it is a weird structure that is incomprehensible by a human brain, as it is so poorly written and organized. Why should one admire the technology if older folks cannot use it? I think words make so much more sense than icons or fancy animations or user interfaces that are expected to feel intuitive. I would rather tell my brain, hey brain, sleep, rather than, hey sleep manager, can you call sleep manager's boss? So it calls boss managers, so it boss manager, so it gives a quick call to the brain, so we get the approval, so we send the boss manager's answers back to the sleep manager boss. You get the point. You can either directly tell, I skipped this part. In fact, I just very vaguely expressed how processes work in computers. You can either directly tell the computer's brain, the kernel, to sleep by writing sleep in the computer console, and that's it. And it's actually not very direct, but that is again not a topic of this discussion. Or you can use a graphics manager, a desktop environment, a graphics server, a graphical menu, an icon bar, a menu bar, and all of those to be able to click a box that shows moon so that your computer sleeps. I'm sorry, but who designed these icons? Moons are not my intuition to sleep. When I see moons, when I see the moon, I stare at it and I feel how beautiful the galaxy is. I don't immediately think of sleep. That does not automatically pop up in my brain. Or when I remove my files from my computer, I don't think of garbage cans, because when I throw garbage in the can, then I have to wait until it piles up, so I go throw it out in a bigger trash can. By the way, when I throw something out in a garbage can, I do not think that I'm ever going to come back to it, because when I throw an unused peeled bananas thing in the garbage can, I'm not thinking that maybe I will sometimes need that banana thing. No, I don't think that, because that is not what happens when you remove a file from a computer. It simply gets deleted from the memory instantly, and I think it is exactly the same as when I throw something that I don't need in a garbage can. I'm not going to come back to it. I don't need it. There was no need to create an application called a trash can that holds on to your files for some arbitrary time that those developers thought they knew was best, and then gets actually removed from the memory of a computer. Computers understand commands in such simple and elegant ways, and I don't think we should continue bloating them this way. Why shouldn't we all strive for a functional yet minimalistic design approaches and choices? Why is time such an important factor that takes away one's own thought freedom away, and we're left with nowadays software as it is? It sincerely makes me sad. I want to make good software. I don't make much, but whatever I do, I want to make it good. And I think we should all. Okay, now I continue. A system ease of use always should be a primary goal, but that ease should be based on an underlying concept that makes the use almost intuitive. Increasingly, people seem to misinterpret complexity as sophistication. Yeah, I think I already read this, which is baffling that incomprehensible should cause suspicion rather than admiration. Possibly this trend results from a mistaken belief that using a somewhat mysterious device confers an aura of power on the user. What it does confer is a feeling of helplessness, if not impotence. Therefore, the lure of complexity as a sales incentive is easily understood, because complexity promotes customer dependence on the vendor. And I have something to say about that as well. I think this one is extremely self-explanatory. Perhaps all the rest were self-explanatory as well, but I still like bringing analogies to different life stories or situations or basically any experience that makes my feelings towards this paper and those quotes specifically so strong. My friend was telling me once that at some point OpenAI or some Cloudflare servers crashed down or something happened and people were not able to use ChatGPT and its services anymore for a day or a few hours. I'm not very sure for how long. She told me that people were creeping out, shooting some videos that is impossible to go on normally with their lives as, oh my god, AI doesn't work today. And that made me remember about how uneducated the public, including me, is on AI. I don't know how AI works, neither frankly I'm interested. As much as I understand from my data scientist friends is that AI is a data array that maps each word to certain numbers and is trained to give answers not logically, but rather logic is defined to it. It's defined to what is the probability of the next word that comes in this sentence to be correct or to be high. The probability to be high. It is being trained the same way as I was when I was learning Japanese, my fourth language. My senseis, my teachers, were giving me sentences that had a blank part in them and asking me what is the next most logical answer. And most of the time, according to my logic, it was wrong, as in that specific context another word was correct. There were too many specific contexts, hence I sort of gave up on learning any more Japanese. I cannot learn one thing that is illogical to me, but AI is better. It can learn what's illogical to it because you define logic for it. Hence, not many of us know how AI works, but in certain cases, we certainly depend on it. For example, I indeed depend on AI for writing emails or responding to coworkers, simply because I did not learn corporate words because they were too complex for me to process. If one day AI ceases to exist, I will have a lot of trouble communicating with my coworkers, as I simply am unaware how to behave not only in social situations but also in a commercial corporate environment. I suppose that is what people meant when they said they can't go on with their days normally. As we can see, AI is extremely complex. It's much more complex than all of us can imagine, and hence it promotes customer dependence on the vendor or the person who provides their AI services. That is essentially why also I think AI services are free, as your data and full profiles on you and your behavioral patterns and your dependence on them is far more expensive than any monthly subscription model or any other payment model. I don't care. So vendor is one that provides products or services to a business for a fee. Is yet another time Wirth has taught me a rather complex word for me, vendor, simply from the context, and I really appreciate this. That is how I believe a language should be learned, but again, that is a topic of another time. and I will continue reading the paper. It's well known, for example, that major software houses have heavily invested with success in customer service, employing hundreds of consultants to answer customer calls around the clock, much more economical for both producer and consumer. However, it would be a product based on a systematic concept, that is, on generally valid rules of inference rather than on tables of rules that are applicable to specific situations only, coupled with systematic documentation and a tutorial. Of course, a customer who pays in advance for a service contract is a more stable income source rather than a customer who has fully mastered a product to use. Industry and academia are probably pursuing very different goals, hence the emergence of another law. Customer dependence is more profitable than customer education. And I think that makes a lot of sense. What I find truly baffling are manuals. Hundreds of pages long, oh my god, I cannot agree with this more, that accompany software applications, programming languages, and operating systems. I wonder how long is Windows operating system documentation or manual, or I don't even want to think about it. Unmistakably, they signal both a contorted design that lacks clear concepts and an intent to hook customers. Yes, because initially as a human, when you see something big, you think it's cool. The same way as when I'm a tutor, I teach math. I teach math to my students who are in 5th or 4th grade, and they always ask me, what is the biggest number? I tell them, there's no such thing as biggest numbers. Numbers are infinite. And then they say, but no, I don't believe you. There is a biggest number in the world. And then they search something up, and they say, did you know there is a number, Google, it has 100 digits or whatever. I don't care what it has, because it's not the concept of it. And it is exactly the same as when people look at a software or at a operating system and they say, oh, it has so many things, it is cool. The same way as my 5th grade students look at a Google number and say that, wow, it's so big, it's so cool. Anyways, the lack of lucid concepts can't alone account for software explosion. Designing solutions for complicated problems, whether in software or hardware, is a difficult, expensive, and time-consuming process. Hardware's improved price-performance ratio has been achieved more from better technology to duplicate, fabricate designs than from better design technique mastery. Software, however, is all design, and its duplication costs the vendor mere pennies. And I cannot even think how much it actually costs, because I believe it is far less than pennies. Initial design for sophisticated software complications are invariably complicated, even when developed by competent engineers. Truly good solutions emerge after iterative improvements or after redesigns that exploit new insights. And the most rewarding iterations are those that result in program simplifications. Evolutions of this kind, however, are extremely rare in current software practice. They require time-consuming thought processes that are rarely rewarded. I truly don't think they are rewarded at all. Instead, software inadequacies are typically corrected by quickly conceived additions that invariably results in the well-known bulk. And I have something to say about that as well. Let's see. This, in my opinion, refers to when there is so much unnecessary words in our essays, we keep trying to artificially insert more to reach the word count. I sincerely have hated every single class I have had that is putting a word count limit on my essays. I know how much I want to say, so I will say that much. There is no need for me to think how to paraphrase a sentence, what synonyms to use, and etc. Other useless crap to reach someone's artificial quota that supposedly makes the essay good. In fact, I think it's quite the opposite. It makes the essay much worse than it should. And it's exactly the same for writing software. Why should software developers struggle to write unreadable, huge, and disgusting code so that corporate approves of their program designs and meets the time constraints, so that they, and by they I mean the self-proclaimed software engineers, can boast to their coworkers or to their students, in fact, or to everyone else that, oh my god, I write 10,000 lines of code every day, I'm so cool. In fact, I think that is bullshit. Time, as Wirth himself has mentioned, puts unnecessary pressure on someone who is trying to create, whom he refers to as an engineer. Engineers need time, and a lot of it, to think about good design choices and program writing principles, and instead of using that time to think, they're forced to bloat the software with additions, and then they try to hide the mistakes by bloating it even more. It is similar to how when in cartoons some wall gets broken and the cartoon characters tape that part with a tape, and more tapes, and then more tapes, and it's a forever loop without actually even considering rebuilding the entire world with better foundation and better structure. Why is it that time is so constrained? And don't even tell me it's because of money. Fuck money. Why is it that because of that, it makes all of our lives so much worse? I do not know. Let's continue reading. Never enough time. Time pressure is probably the foremost reason behind the emergence of bulky software. The time pressure that designers endure discourages careful planning. It also discourages improving acceptable solutions. Instead, it encourages quickly conceived software additions and corrections. Time pressure gradually corrupts an engineer's standard of quality and perfection. It has a detrimental effect on people as well as products. The fact that the vendor whose product is first on the market is generally more successful than the competitor who arrives second, although with a better design, is another detrimental contribution to the computer industry. And this is comparable to McDonald's. Why is it the best? Because it was the first. But nowadays, do you really go to McDonald's when you have nowhere else to go to for food? Is that really your first choice for a fast food? McDonald's? I do not think so. Good engineering is characterized by a gradual, stepwise refinement of products that yields increased performance under given constraints and with given resources. Software's resource limitations are believably ignored. However, rapid increases in a processor's speed and memory size are commonly believed to compensate for sloppy software design. Meticulous engineering habits do not pay off in the short run, which is one reason why software plays a dubious role among established engineering disciplines. I'm not even going to comment on that. Languages and design methodology. Although software research, which theoretically holds the key to many future technologies, has been heavily supported, its results are seemingly irrelevant to the industry. I wonder why. Methodical design, for example, is apparently undesirable because products so developed take too much time to market. Analytical verification and correctness proof techniques fare even worse. In addition, these methods require a higher intellectual caliber than that required by the customary try and fix it approach. To reduce software complexity by concentrating only on the essentials is a proposal swiftly dismissed as a ridiculous in view of customers' love for bells and whistles. When everything goes in the modus operandi, methodologies and disciplines are the first casualties. Programming languages methodologies are particularly controversial. In the 1970s, it was widely believed that program designs must be based on well-structured methods and layers of abstraction with clearly defined specifications. And we can see what is written here. Abstraction works only with languages that postulate strict typing, and we'll talk about strict typing later. The abstract data type best exemplifies this idea and found expression in then new languages such as Model 2 and Ada. Today, programmers are abandoning well-structured languages and migrating mostly to C, and this paper was written in 1990-something, or 1980 something. And this speculation that they're migrating mostly to C, I mean, not a speculation, this fact, it has continued, and everyone is still on that right now. The C language doesn't even let compilers perform secure type checking, yet this compiler task is by far most helpful to program development in locating early conceptual mistakes. Without type checking, the notion of abstraction in programming languages remains hollow and academic. I will quote on this later. Abstraction can work only with languages that postulate strict static typing of every variable and function. In this respect, C fails. It resembles assembler code where everything just goes and everything just runs. And let me tell you about my thoughts on that. So, quote, yet this compiler task is by far most helpful to program development in locating early conceptual mistakes. I actually have not written much code myself, but I did write some, as I'm unfortunately a computer science bachelor's graduate and I had a few programming assignments. I wrote code in many proprietary languages, per se, Java, C, C++, JavaScript, Python. My whole university life and career, I thought that that's it. I cannot write any programs without understanding how things work from the ground up. 1, and 2, I cannot design any software with languages that have so many library and package dependencies that I'm simply expected to know how to use. There have been countless times I went to some professor's office hours and asked, hey, what does this library do? What are you writing right now? And then they simply laughed at me. For a long time I thought I was wrong here. Maybe it is actually supposed to be like that. I thought, well, if I am, for example, hired to be an AI Python developer and I write data.train, I'm supposed to understand how it works on the job spot. Turns out that is wrong. I have personally never stepped foot in IT corporate environments, but to me, to pay a person to use Python and write data.train on a daily basis, monthly, a salary much more than to a fast worker salary, is absurd. And by this, I'm not claiming that that is what every single Python AI developer does. I'm saying that I sincerely don't think that it is fair. And then one day, I accidentally chose a professor whose name I did not know for my computer organization class, and I thought, I hope this one will be better than the other one based off of my university students' Facebook feedbacks. There was a Facebook feedback place in my university where they write the name and the surname of a professor, and some people leave some whatever comments they think about it, and then I read and I try to understand who do I trust more with what, and then there were almost no comments. There were actually no comments on that professor, so I was like, I don't know, this one is a bet. It is gonna be either a 100% great one or no, or actually no, but anyways. So, where did I go? So yeah, and I thought, I hope this one will be better than the other ones. He has introduced me to the world of FOSS, free and open source software, and privacy and efficiency, and finally to the two extremely cool programming languages, Oberon and Pascal. For the former, he has written his own compiler. Isn't that cool? Every programming language has its own compiler. And why is it that I struggled so much writing C-based languages codes? All of the languages there, Java, JavaScript, C++, whatever, they are C-based simply because of the extremely bad compilers with useless messages and warnings and useless error codes. And then all the time you have to struggle, you have to go to a browser, you have to ask, you have to look at the forums, you have to try to find an answer to a problem that is, in my opinion, in fact, useless. Because when I wrote code in Oberon, and when I realized that in my monitor, all I'm doing is I'm simply looking at the 62-page documentation for it that Wirth has written, and simply looking at my terminal console for the compiler error messages, and then building it. That's it. 3-window workflow that I had, and it was amazing. I did not need to search up examples, forums, ask AIs. I did not need that, simply because the compiler and the language was so great, and because I was writing a small and simple program. And to this day, I'm so grateful and forever will be to him for introducing me to this little world and for supporting me and helping me in everything so far. Thank you so much, Inky, if you are reading or watching this. And then, without type checking, the notion of abstraction in programming languages remains hollow and academic. And my thought on that is that was the quote, and my thought on that is that the programming language, a good one, that is, should have a clear way of an abstracting notion. That is, a programmer should have a clear and intuitive way of writing the program such that each variable has a meaningful position, each structure is well defined, each method is simple and modular, that editing and understanding your own code should be easy if you ever come back to it. And thus, abstraction can be achieved. What is abstraction, however, in greater detail, I will not address, as I don't want to get in too much detail. It means exactly what the meaning of the English word abstraction has, which is it is something non-specific, a concept that isn't concrete, so it is an act or a process of making logical generalizations. And then, quote, static typing lets the compiler pinpoint inconsistencies before program execution. I think, did we read this so far? Okay, I will leave my comments just in case and we'll continue reading, but it is related to it. We already talked about static typing, so let me say. It is so important to realize and to think about the security of your own program. A method in a program is defined as a procedure that has a specific instructions set. That method may have some input required. For example, there is a method add AB, and you can guess what it should do. The programmer, when writes such methods, needs to think about the potential issues that method may raise. For example, what will happen if someone writes a text instead of A and a floating point number for B? C has this issue that it's possible to trick it and give one's computer potential memory leakage, as it will perhaps try to access a number or a data that does not exist. So the compiler will search for it in the entire memory address space, and it may even not give a warning or an error, and it will just compile it like normally. Static typing refers to writing code with strong type checkers, so such errors become preventable compile time before execution. Now imagine how insecure all of our software is, as it is mainly originating from C. And the reason for it is that the corporate rushed the developers, and the developers kept making C bigger and bigger, and it is inevitable at this moment for any of us to avoid it. But again, I'll talk about it or write about it another time. Now let's continue. Reinventing the wheel. Remarkably enough, the abstract data type has reappeared 25 years after its invention under the heading object-oriented. This modern term's essence, regarded by many as a panacea, I don't know how to pronounce it, concerns the construction of class-type hierarchies. Although the older concept hasn't caught on without the newer description object-oriented, programmers recognize the instinctive strength of the abstract data type and convert to it. So you see how it is this term object-oriented is simply just another marketing term. To be worthy of the description, an object-oriented language must embody strict static typing that cannot be breached, whereby programmers can rely on the compiler to identify inconsistencies like we were talking about. Unfortunately, the most popular object-oriented language, C++, is no help here because it has been declared to be upwardly compatible with its ancestor C. Its widely acceptance confirms the following laws. Progress is acceptable only if it's compatible with the current state. Adhering to a standard is always safer. And that is exactly the same as when corporate recruiters are hiring for candidates, because adhering to a standard is always safer. For example, It is always safer to hire a native Chinese speaker for a Chinese teacher rather than someone who has learned Chinese as their second language. And in my opinion, it is much more logical to hire someone who learned the language for their second language. You know why? Because they understand the issues, the struggles that you face when you learn the language. Because when you learn the language as a native, you don't think about it the same way as when you learn it as your second or third or fourth language. And I think it makes perfect sense to hire then the natives. But hiring the natives is the standard. And like Wirth saying, adhering to a standard is always safer. Of course it's always safer. Given this situation, programmers struggle with a language that discourages structured thinking and disciplined program construction, and denies basic compiler support. They also resort to makeshift tools that chiefly add to software's bulk. With the grim picture, what a pessimist. The reader must be thinking, no hint of computer's bright future, therefore regarded as a given. Is anyone thinking about that? I'm not. This admittedly somber view is realistic. Nonetheless, given the will, there is a way to improve the state of the art, which is Project Oberon. But before that I want to check if I missed on something. I feel like I missed on something. I think I didn't talk about this part. Okay, I'll talk about this later. Wait, but did I miss a page or something? No. No, we talk about this. We talk about this. Best optional larger because hardware advanced think is value. We talk about this. No. But then why did I forget to talk about my comments? Anyways. Good engineering is characterized by a gradual, stepwise refinement of products. Okay, before we talk about Project Oberon, I want to leave comments on this, about good engineering, stepwise refinement of products. And there is this quote of Wirth that a system that is not understood by its entirety, or at least a significant degree of detail, by a single individual should probably not be built, quote. And why is that? Because would you try to make ultra-processed food like potato chips at home? You would need factory-grade level equipment, a lot of chemical substances, and it would cost you a lot of money. There is a reason such foods are called ultra-processed, as you simply cannot make them at home, unless you're a billionaire with a lot of free time on their hands. In my opinion, mindlessly using Windows simply because it is convenient is the same as making ultra-processed chips at home instead of eating potato chips that you make, is because they taste better than the ones that you make. There is a reason that doctors advises to consume ingredients rather than ultra-processed foods, and that, in my opinion, is the same as using bulky software every single day instead of using good software, making good software, using a simple, free, open source operating system. And I don't know why would you ever pay $200 or however there is to Windows or to macOS to use their bulky operating system when you can simply use Linux. It's free. And then, quote, reducing complexity and size must be the goal in every step. I believe this concerns to not only software, but absolutely every principle in life. Let's say any type of corporate work, if we work while having in mind that we should try to reduce complexity and size of our projects, everything would rather be compact and beautiful. Unlike my current notes, let's say, the smaller and the more meaningful the paper is, the more meaningful it is for everyone else. It is not my job to write papers, but I want to write them good. I have heard numerous stories that when because people finished their corporate work a few minutes or hours early, they had to pretend they were still at work so that they are not given any more unnecessary assignments. Yet it is so simple to operate with principles that rely on efficiency and simplicity, rather than the exact opposite that corporate does. Hard work should not be praised. Struggling should not be praised. Sleeping less than the human body functionable amount should not be praised. Yet they are. And why have I come to this conclusion is because when I was studying computer science in my university, almost every single person in my environment would always tell, and I think that is boasting off, that they have only slept 3 hours to prepare for an exam, or that they have only slept 4 hours to write something. And I think that is absolute bullshit. I cannot imagine a person feeling proud of themselves, feeling accepted in a society because they did not sleep the required amount for their body to function. I cannot ever imagine that it is praised and accepted, but it is. Because that is how one is expected to succeed in the society. It is through struggle and hard work. Because nowadays, nobody really is going to reward you for your simple and efficient solution. They're going to reward you with your word count of your essay or with your lines of code that you write. Oh my god, I remember I had what was it? I had some kind of... what was the name of that class? Oh yeah, I had a cybersecurity class professor, and I swear to God, every single day we had a class, he would tell the students, oh, today guys, I wrote 6,500 lines of code. You should all try to be like me. I'm so cool. And honestly, I do not know why I didn't drop that class that same second that he said it in the first day of the class, and then every single time was saying that. That is so fucking dumb. And I think Elon Musk claiming to have worked 16 hours a day to earn what he has now, it's got to be the funniest claim ever. And then there is another quote from Wirth, that a programmer's competence should be judged by the ability to find simple solutions, and certainly not by the productivity measured in the number of lines ejected per day. I don't understand anyone not agreeing with this. And then, quote, programs should be written and polished until they acquire publishing quality, and should be written for human readers as well as computers, and not so that they just run. And you know, when I visit many bookstores in Japan, as I currently live here, I always find a really small number of book sections labeled as PC. And when I go there, I find so many books on Excel, that yes, Excel software from Microsoft, themed as something like Excel Introduction. What would you feel if there were many mass-produced books for every single software? Why is there one on Excel? Why not YouTube? Why not any? I do not understand this. I feel confused. But then I understood Excel is something Japanese people are expected to know and use it on a daily basis in their work environments. So probably when they feel like they can't understand it, they want some kind of a resource or a way to learn how to use it with examples and everything of that sort. Now, imagine every other single software had all of these thick million-page books of how to use them. I would go crazy, to be honest. And that simply just tells me that Excel is so bulky and so bloated and so bad and confusing that so many Japanese people needed a book to explain how to use a software to them, and it results in mass production of this Excel introduction complete from beginners to book. What the fuck? Software doesn't need any self-explanatory books. It is ridiculous. And then I talked about the compiler. Yes, I think the rest I talked about. So now let's read about Project Oberon. Between 1986 and 1989, Jörg Gottnicht, I'm sorry, I have no idea how to pronounce this guy's name, and I, Niklaus Wirth, designed and implemented a new software system called Oberon for modern workstations based on nothing but hardware. Isn't that mind-blowing? Our primary goal was to show that software can be developed with a fraction of the memory capacity and processor's powers usually required without sacrificing flexibility, functionality, or user convenience, aka a good fucking system. The Oberon system has been in use since 1989, serving purposes that include document preparation, software development, and computer-aided design of electronic circuits, among many others. The system includes a store management, a file system, a window displaying manager, a network with servers, a compiler, and text graphics and document editors. Designed and implemented from scratch by 2 people within 3 years, Oberon has since been ported to several commercially available workstations and has found many enthusiastic users, particularly since it is freely available. Our secondary goal was to design a system that could be studied and explained in detail, a system suitable as a software design case study that could be penetrated top-down and whose design decisions could be stated explicitly. That also reminds me of the Minx system of Andrew Tannenbaum. He created the system to teach his computer science students, and I believe this is absolutely similar, and it is absolutely mind-blowing that people like Wirth and Andrew Tannenbaum existed and they had so much contribution, yet they do not have recognition. They are not as famous as fucking Elon Musk, whatever. How is it possible to build a software? Oh wait, I missed something. Indeed, there is a lack of published case studies in software construction, which becomes all the more evident when one is faced with the task of teaching courses. The result of our efforts in a single book that describes the entire system and contains the source code of all modules. How is it possible to build a software system with some 5 man-years of effort and present it in a single book? Because the man knows how to fucking write good software and good books and good literature. This literature is the best thing I've ever read. Now, 3 underlying tenets. First, we concentrated on the essentials. That's it. They do not want to bloat the fuck out of you. They want to give you the essentials. We omitted anything that didn't fundamentally contribute to power and flexibility. For example, user interaction in the basic system is confined to textual information. No graphics, pictures, or icons. Simply textual information. Secondly, we wanted to use a truly object-oriented programming language, one that was type-safe. This, coupled with our belief that the first tenet must apply even more stringently to the tools, I need to relearn these words, than to the system being built, forced us to design our own language and to construct its compiler as well. It led to Oberon, a language derived from Modulo 2, by eliminating less essential features like subrange and enumeration types. Oh my god, and addition to features known to be unsafe, like type transfer functions. Fuck Java, bro, and JavaScript, and Python, and everything of that sort, like type transfer functions and variant records. And before I continue, I want to tell you about something that I didn't write in my paper, but I will talk about it now. So, the same thing, the same bloated software is IDEs, integrated development environment. Their marketing strategy is that we are so good and so nice that we give you a workstation so that you can work on your code. You can use our a graphical representation of a console, with a build console, with a display console, with a compiler console. You have these 4 windows in one place that we gathered for you because we're so nice, and now we're selling it to you. And you know what is fucking so annoying? That in all of my programming classes, where the professors were forcing, like actually forcing every single student, and especially me, because I did not fucking want to use any IDEs, to use ones. I was simply going to them to ask a question about your goddamn fucking program. What does this do? And then I'm showing them my simple Vim text editor, and then they stare at me. They're like, the error? Oh, that's because you're not using this visual code. That's because you're not using this Java IDE, whatever. Seriously, you think that the reason that my program's error popped up is because the same fucking Java compiler that runs in my own fucking terminal is wrong because it does not run in the IDE's integrated fucking terminal? That is insane. I do not understand how those people were able to become professors. How can you teach someone that I want you to use an IDE because that's the fucking standard? And again, we go back to the same quote of Wirth, that it is always safe to adhere to the standard. But then I don't want to use your fucking IDE. I want to have my window of a compiler, my window of an editor, Vim, my window of the build, and that's it. And the documentation for Windows, or literally console windows. You understand the point. Anyways, this is sincerely making me mad because I keep remembering about that professor that was blaming my code is wrong because I'm not using IDE. That's fucking insane, bro. Okay, and then lastly, to be simple, efficient, and useful, we wanted the system to be flexibly extensible. So cool. This meant that new modules could be added that incorporate new procedures based on calling existing ones. It also meant that new data types could be defined in new modules compatible with existing types. We call these extended types, and they constitute the only fundamental concepts that was added to Modulo 2. No, type extension. If, for example, a type viewer is defined in a module called viewers, then a type text viewer can be defined as an extension of a viewer. Isn't that intuitive? Doesn't that make sense? Whatever operations apply to viewers apply equally to text viewers because they are inverted. And whatever properties viewers have, text viewers have as well. That makes sense. Extensibility guarantees that modules may later be added to the system without requiring either changes or recompilation. Exactly, because their system is beautiful. It is modular. With obviously type safety is crucial and must cross module boundaries. Type extension is a typical object-oriented feature. To avoid misleading astromorphism, we prefer to say text viewers are compatible with viewers rather than text viewers inherit from viewers, but I think we already understand what they want to say. We also avoid introducing an entirely new nomenclature for well-known concepts. For example, we stick to the term type, avoiding the word class. Fuck the word class. It is not a class, it is a type. We retain the term variable and procedures, avoiding the new terms instance and method. Clearly, our first attempt, concentrating on essentials, also applies on terminology, and oh my god, I cannot agree with this more. And we go back to the same idea that I had on corporate terminology. Tell me, why do I need to say, actually, I am in the process of considering your request, but as of now, I am unable to proceed with it, instead of fucking saying no? Tale of a data type. An example of a data type will illustrate our strategy of building basic functionality in a core system with features added according to the system's extensibility. In this system's core, the data type text is defined as character sequences with the attributes of font, offset, and color. Basic editing operations are provided in a module called text frames. An electronic mail module is not included in the core, but can be added when there is a demand. When it is added, the electronic mail module relies on the core or system and imports the types text and text frame displaying text. This means that normal editing operations can be applied to received email messages. The messages can be modified, copied, and inserted into other text visible on the screen displaying by using core operations. Mind you, all of this is all text-based. The only operations that the email module uniquely provides are receiving, sending, and deleting a message, plus a command list in the mailbox directory. Operation activation. Another example that illustrates our strategy is the activation of operations. Programs are not executed in Oberon. Instead, individual procedures are exported from modules. If a certain module M exports a procedure P, then P can be called, activated by merely pointing at the module, right? The string MP appearing in any text visible on the display, that is, by moving the cursor to m.p and clicking a mouse button. Such straightforward command activation opens the following possibilities. 1. Frequently used commands are listed in short pieces of text. These are called tool text and resemble customized menus, although no special menu software is required. They are typically displayed in small viewers windows. By extending the system with a simple graphics editor that provides captions based on Oberon texts, commands can be highlighted and otherwise decorated with boxes and shadings. This results in pop-up and or pull-down menus, buttons, and icons that are free because the basic command activation mechanism is reused. A message received by email can contain commands as well as text. Commands are executed by the recipients clicking into the message without copying into a specific command window. We use this feature, for example, when announcing new or updated module releases. So cool. The message typically contains receive commands followed by a list of module names to be downloaded from the network. The entire process requires only a few mouse clicks, keeping it simple. The strategy of keeping the core system simple but extensible rewards the modest user. The Oberon core occupies fewer than 200 kilobytes. Now, can you imagine all of what they said that they focused on their essential? Storage management, file system, window display manager, network with servers, a compiler, a text, graphics, document editor. All of that, including the editor and the compiler, is 200 kilobytes. It is absolutely mind-blowing to me. A computer system based on Oberon needs to be expanded only if large, demanding applications are requested, such as CD with large memory requirements. God. If several such applications are used, the system does not require them to be simultaneously loaded, and this is so cool. The economy is achieved by the following system properties. 1. Modules can be loaded on demand. Again, this is based on the modular structure of their system, because modules can be loaded on demand. They're not always loaded. There's no fucking load going on in the background that you don't even know, that I don't know, that Windows does it that way, and I don't want to know how they do it. Anyways, demand is signaled either when a command is activated, which is defined in a module not already loaded, or when a module being loaded imports another module not already present. Module loading can also result from data access. For example, when a document that contains graphical elements is accessed by an editor whose graphics package is not open, then this access inherently triggers its loading. 2. Every module is in memory at most once. At most once. Oh my god. This rule prohibits the creation of linked load files, core images. Typically, linked load files are introduced in operating systems because the process of linking is complicated and time-consuming, sometimes more so than the compilation. So, can you imagine the process of linking files is more complicated than compiling them? And you know why their system is so good? is because the module is in the memory at most 1, so it cannot be 2. There cannot be 2 modules in the memory at once. Wow, that is so cool. With Oberon, linking cannot be separated from loading. This is entirely acceptable because the intertwined activities are very fast. They happen automatically the first time a module is referenced. Again, the price of simplicity. The experienced engineer, realizing that free lunches never are, will now ask, where is the price for this economy hidden? A simplified answer is, in a clear conceptual basis and a well-conceived appropriate system structure. You know, that is so obvious, but why does nobody realize that? If the core or any other module is to be successfully extendable, its designer must understand how it will be used. Indeed, the most demanding aspect of a system design is its decomposition into modules. Each module is a part with a precisely defined interface that specifies imports and exports. And this reminds me of when I was studying physics in my school as my core subject, because I had a choice to choose something for high school. I said, well, let it be physics. I don't care. Physics is cool. And you know what my teacher was always saying? That every single process that the humanity has invented so far, every single formula, every single logic that explains things, is because they are divided in tiny, tiny pieces, and each piece is explainable, each piece is interactable, each piece is, therefore this entire system is connected with each other, and therefore this entire system is modular. That is what it means to be a modular system. For example, why was there a need to create, how did someone create electricity? Because apes of their time created fire, and then they created other structures, and I'm not very good at explaining this, but you get the point. There has to be a well-defined and an intuitive, logical chain of steps that overall works together as a system. For example, that is the same as industrialization of countries and cities, but I'm not very knowledgeable on those. With the analogy, you get the point, I hope. So I will not explain those. And then, each module also encapsulates implementation techniques. All of its procedures must be consistent with respect to handling its exported data types. Precisely defining the right decomposition is difficult and can rarely be achieved without iterations. Iterative tuning improvements are, of course, only possible up to the time of system release. It is difficult to generalize design rules. No comments on that. Obvious. If an abstract data type is defined, carefully deliberated basic operations must accompany it. But composite operations should be avoided. It's also safe to say that the long accepted rule of specification before implementation must be relaxed. Specifications can turn out to be unsuitable, as implementations can turn out to be wrong. In conclusion, here are 9 lessons learned from the Project Oberon that might be worth considering by anyone embarking on a new software design. And I think it is not only about software design, it is about our entire fucking life. 1. The exclusive use of a strongly typed language was the most influential factor in designing this complex system in such a short time. The manpower was a small fraction of what would typically be expended for comparatively sized project based on other languages. Static typing A lets the compiler pinpoint inconsistencies before program execution. That means you can prevent memory leakage. C. Look and learn. B. Let the designer change definitions and structures with less danger of negative consequences. Again, C with your fucking header files. Look and learn. C. And C speeds up the improvement process, which could include changes that might not otherwise be considered feasible. 2. The most difficult design task is to find the most appropriate decomposition of the whole into module hierarchy, minimizing function and code duplication. Oberon is highly supportive in this respect by carrying type checks over module boundaries. Exactly, because we're putting type checking into the highest priority. And I simply don't understand why type checking has not been the highest priority in the entire development of human nature and of humanity's software and everything that exists right now. Type checking, not giving like reward to someone who pays attention to type checking, makes a system out of it, makes a fucking programming language, Oberon and Pascal, and then rewarding someone who creates a corporate system that relies on the core dependence and a brain dead functionality, or rather I would say non-functionality of a brain, or even an absence of a brain of a customer. What a world. 3. Oberon's type extensions construct was essential for designing an extensible system where in new modules added functionality and new object classes integrated compatibility with its existing classes or data types. Extensibility is prerequisite to keeping a system streamlined from the outset. It also permits the system to be customized to accommodate specific applications at any time, notably without access to the source code. 4. In an extensible system, the key issue is to identify those primitives that offer the most flexibility for extensions, while avoiding a proliferation of primitives. 5. The belief that complex systems require armies of designers and programmers is wrong. A system that is not understood in its entirety, or at least to a significant degree of detail by a single individual, should probably not be built. Yeah, this is where I took my quote from, and I think I already talked about it. Yeah. Let me see. Yeah, I already talked about it. Yeah. And then, communication problems grow as the size of the design team grows, whether they are obvious or not. When a communication problem predominates, the team and the project are both in deep trouble. Exactly, and this communication does not concern only to the communication between human and human. It is also the same as a communication between a programmer or a human with a computer, because that should also be valued. So when software is created, let's say software's user interaction with software should be as important as, let's say, fucking type checking. 7. Reducing complexity and size must be the goal in every step in system specification, design, and in detailed programming. A programmer's competence should be judged by the ability to find simple solutions, certainly not by productivity measured in the number of lines ejected per day. And we already talked about this. Prolific programmers contribute to certain disaster. And by the way, I read my opinionated essay or paper, whatever, to my friend, and on this she said something like, so from a third person's perspective, I think that what you are saying is that the current system is unfair, and it gives the current system that is like my idea. It gives privilege to those who finish their work early, and it gives and does not reward people who finish their work late. And to comment on that, I am not saying, first of all, that the system is fair. I did not comment at all on the fairness of any systems. 2, I'm simply saying that if today's work is to create a website that is blue, that has the word hello on it, then if a person named Tanaka-san finished this website project in 2 hours, and if I finished it in 3 hours, then I think Tanaka-san should go home after 2 hours, and I should go home after 3 hours. And why is it that? Because there is no need to ask Tanaka-san to stay after he has already finished your day, to continue staying after they've already finished their work. It's insane. I don't understand why people in their corporate work environments, they have to pretend to work instead of going to their manager and saying that I finished my task for today. You gave me tasks, I finished. Can I go home? I don't understand why it's not a fucking standard to just ask your manager to please why do you need an approval to leave early if you've already done your work? I simply don't understand it. I don't know. I really don't. Like, for example, when I do my math tutoring, I try, and my classes are, let's say, 1 hour or 1.5 hours, and when I do my tutoring, I first try to understand, like, what material is there, so, like, what do we have to do, 1, and 2, I try to understand, like, how can I deliver them this material as soon as possible, so then I can keep giving them practice problems. And ideally, I like to first explain the topic in like 10 or 15 minutes or something, and then give them practice problems. So we never ever have any time issues. Just because they're paying me for 1 hour, we do the class for 1 hour. We could have done the same class for just 15 minutes, and I just give them the practice problems later, and then they do that on their own. That, in my opinion, would have been better, but because my students are lazy, and I have to babysit them, that's why I give them problems after my explanation, and then they do it. And that's why this tutoring system that I have worked out in my own brain makes sense and is logical, in my opinion. Because for example, if we finish some kind of a topic and then we do some, let's say, 2 or 3 or 4 or 5 practice problems, and I already think that this student has already mastered it, there is no other problem that I can give to this student and that they wouldn't do it. In that case, I just simply finish the class early, because there is no need to keep bloating their brain with unnecessary exercises. That is how I do my math classes as a math tutor. And there have been a few times where I finished the class, let's say 10 minutes early or 5 minutes early, or sometimes I even finished it 20 minutes early, because that's how my students at that time, that's how fast they were able to grasp today's concepts. And that's what I'm trying to say this whole time. I'm just trying to say that things should be simple. That's it. And then 8. To gain experience, there is no substitute for one's own programming effort. Well, that is inevitable. Organizing a team into managers, designers, programmers, analysts, and users is detrimental. All should participate with differing degrees of emphasis in all aspects of development. In particularly, everyone, including managers, should also be product users for a time. This last measure is the best guarantee to correct mistakes and perhaps also to eliminate redundancies. I don't understand why managers don't try their own software before fucking making it released to the public. I don't get it. 9. Programs should be written and polished until they acquire publication quality. Period. It is infinitely more demanding to design a publishable program than one that runs. Programs should be written for human readers as well as for computers. If this notion contradicts certain vested interests in the commercial world, it should at least find no resistance in academia. With Project Oberon, we have demonstrated that flexible and powerful systems can be built with substantially fewer resources and less time than usual. The plague of software explosions is not a law of nature. It is avoidable, and it is the software engineer's task to curtail it. Now, tell me that this is the best paper that you have ever read your whole life. And this, when I read this, when I first read it, and this is the third time that I'm reading this paper, when the first time I read this, I felt like the humanity in humans still exists. I felt like Wirth understands what is important. I feel like if Wirth had a company with people who create a blue website that says hello, that is today's task, then he would let them go home, because I think it makes sense. Anyways, now let's read a little bit more about Niklaus Wirth, and then I'll close the paper. Niklaus Wirth is a professor of computer science. Actually, he was, because he recently died, to my knowledge. Very, very unfortunately, rest in peace, Professor Niklaus Wirth. He was a computer science at the Swiss Federal Institute of Technology, ETH, in Zurich. He designed the programming language Pascal, Modula, and Operon, and the workstations Lilith and Cirrus, as well as their operating software. I just don't know how to pronounce them. Wirth received PhD from the University of California at Berkeley. He was awarded the IEEE Emmanuel Prior Prize and the ICM Turing Award. He was named a computer pioneer by the IEEE Computer Society and is a foreign associate of the National Academy of Engineering. Readers can contact the author. I don't think they can contact him anymore at this email. And thank you anyone who has watched the video until now, or thank you anyone who has read my paper.